All right, so today what we're going to do is we're going to work through the geometry EOC from 2025 that was released. So this was last year's geometry test. And so I'm going to focus as I try to solve this on more strategy, not necessarily always on content, but just how do we kind of approach these problems and what do we do about this, right? So first thing to note is we've got a couple of tools available to us, right? So we got here your reference sheet, which has all kinds of formulas and stuff in there that we can use to reference. The second thing is this kind of inherent calculator, so this Desmos Scientific, which you can use. And so what I'm going to do is kind of talk through how to do this and use those resources. You'll see me kind of pull those up throughout. So to start, we've got two statements about triangle JKL are shown. The measure of angle L is 90 degrees, and the sine of J is equal to 99 over 101. Okay, and so if I draw this image, right, we can actually kind of figure this out just by making the picture, right? So L is 90 degrees. They're telling us that means we have a right angle in our triangle, which is angle L. We also means this is a right triangle. Therefore, we can kind of use this trigonometry stuff, right? And so triangle JKL, that means J and K must be the acute angles. You could label them either one. It really doesn't matter for this purpose here. And so the other thing we know is the sine of J is equal to 99 over 101, right? So if we go look at our reference sheet here, or if you just remember generally from SOHCAHTOA, right, sine is equal to the opposite over the hypotenuse. And so what that means is if I look at the information given here, compared to angle J, 99 must be the opposite, and therefore 101 must be the hypotenuse, right? Okay, and so then for what we want to find is the ratio that represents the cosine of K. Okay, and so with respect to K, 99 is not the opposite anymore because K is adjacent to this side. The 99 is the adjacent, and that 101 is still my hypotenuse. That's still the side across on the right angle. And so cosine of K is going to be equal to the adjacent over the hypotenuse, right? So that's cosine. And so in this case, that's going to be 99 over 101. It's the exact same as our sine here. But if you don't draw that image, it's going to be a little bit harder to see what's going on. For question number 2, okay, we've got line segment MN, okay, and it has endpoints M and N, right? And they'll give us the full coordinates for this. Right. And so what I want to find is the point P somewhere in the middle of MN that's going to split this in a ratio so that M to P or MP to PN is going to be 2 to 1. So we're splitting this in a ratio of 2 to 1. And specifically, this question's only asking for the X coordinate. You could repeat the procedure I'm going to show you with the Y coordinate. It would work as well. And so the way that I think about it is like this. If I look at where these coordinates are, I've got -7 for M, -1 for N, and I'm just looking at the X because we just need to find the X here. I need to find this P, so that's going to split this into that ratio. There is a formula that we can use to kind of solve this, but I can never remember what it is. And even when I do, I often plug the wrong thing in the wrong spot. And so how I approach it is like this. Okay, if I want to break this into a ratio of 2 to 1, that means that I'm going to make this into like 3 equal chunks, right? 2 for this first group and then 1 for the second group. And that will split in a ratio of 2 to 1. So I need to know how long is this total thing? Well, from -7 to -1, that means this is the distance here is 6 from M to N, right? The length of that is 6. And so if I want to split that into 3 equal chunks or 3 equal pieces, we'll divide that by 3. So each one of those pieces is 2. And so if I'm giving 2 of those to this here, that means that this length or this segment should be 4. And I'll put one of those pieces here. This segment should be 2 long, right? And so that makes up my total 6. And so now I want to say, well, okay, what's 4 to the right of -7 or 2 to the left of -1? Either way, we end up at P being at -3. And so that's going to be the X coordinate for point P. We could also repeat this procedure to find the Y if that was necessary. In this problem, we don't need to do that. For question number 3, we've got this statements about dilation. So 1, 2, 3, 4 statements about dilations. And all you need to know about this is that if your scale factor K is more than 1, then your dilation is an enlargement, meaning every side length the area, the volume, all that should increase. If your K is less than 1, or really more specifically between 0 and 1, then you're getting a reduction in your side length, your volume, and your area should all decrease. So we just need to compare, right? For this first one, I've got a scale factor that's less than 1. That means we should have a decrease, and this is saying an increase, so that's going to be incorrect. For part B, we've got a scale factor less than 1. They're saying no change in volume. That's only going to happen if your scale factor is, in fact, just 1. So that's not true. For part C, we've got a scale factor more than 1, but they're saying that results in a decrease, and so that's also false. Lastly, we have 3.5 results in an increase in surface area. That'd also be true for volume and side lengths, but we just generally need to know that, right? More than 1 means we're got an increase. And so for this one, our answer is going to be D. Question 4, we've got two parallel lines, F and G, that are cut by transversal H as shown. We got this diagram here. And we need to find, this is a free response question, we need to find the values of X and Y. So we need to remember our relationships, right? So here I've got two parallel lines, and this angle 94 and this angle X are consecutive interior angles. So 94 and X are consecutive interior angles. And what we know about our transversals is that if these lines are parallel, then consecutive interior angles are supplementary. That is, they are going to add to 180. And so if I subtract 94, I get that X is equal to 86. So that means this angle here is 86 degrees, and that will make these two add up to 180. Okay, what we also know is that this angle and this angle are alternate interior angles, right? They're not numbered or lettered, or I'd say their names, but these are alternate interior angles. And so that means that 94 must be equal to X plus Y. Okay, these two are going to be congruent. And so the thing is, we just found what X is. X is 86. And so 94 must be equal to 86 plus Y. If I subtract 94, then for Y, I'm going to get it is equal to 8. Question number 5. So in question number 5, we're talking about parallelograms. And so for this one, you're going to have to kind of remember some of the special relationships that are things that happen between particular ones, right? So for a general parallelogram, what we know is that opposite angles are congruent, opposite sides are congruent, and then the diagonals bisect each other. So that's going to be true for our parallelograms, for any parallelogram. And so when we go in here and we see something like, okay, diagonals are congruent. So we might remember there are some types of parallelograms that have that, right? But we can check, right? And one of the ways to kind of check if you can't remember is to do something ridiculous, right? But that also fulfills the criteria. So for instance, let me make a rhombus where it'll be very clear, right, from this rhombus, if these are parallel and these are parallel, right? We got a parallelogram and these are also all the same length, then that means this is a rhombus, right? But I've very clearly drawn this in a way that these diagonals are certainly not going to be equal in length, right? I specifically drew these to be closer than these, so we can see there are some parallelograms where the diagonals are not congruent. And so therefore, this can't be true for all of them, okay? Now, similarly here, right, this one will be better served if you draw it on like a coordinate plane. So you'd want to draw them a little bit more specifically, but if you make a diagram, you'll be able to see, especially if you can use some sort of graph to prove this, that the diagonals are not going to be perpendicular for most of our parallelograms. Okay, opposite angles are complementary. So complementary means adds to 90 degrees. And so if you have a parallelogram, right, where maybe those acute opposite angles are both 45, okay, 45 and 45, that's complementary. So there's one example where it does happen, but I could just as easily have a parallelogram where those opposite acute angles are maybe 46 and 46, right? And that's no longer complementary. That adds to 92. So that's not going to be true of all of them. What we do know is that consecutive angles are always going to be supplementary, right? Because I know that this angle and this angle are essentially consecutive interior angles on a transversal. And so for this one, our answer is going to be D. But if you don't remember how to do these, maybe the strategy is to try to rule out and prove, right, a little bit indirectly, or not indirectly, but rather a little bit more vaguely, informally, that that is not true. For question 6, we've got this conditional statement. If P, two shapes are given in circles, then Q, the shapes are similar. So the inverse, not the inverse, the converse means we basically take these statements and we swap them. So if the shapes are similar, then the two given shapes are circles. And so when we're looking at these three, only one of these doesn't have that kind of not in it. That's going to be the second one. So if the two given shapes are similar, there's my Q, then the shapes are circle, there's my P. So that's the converse, where you just kind of flip the order of them. The inverse is we take our two statements and we negate them. Just we keep the order, but we say if not two given shapes are circles, then not the shapes are similar. However, they'll put that a little bit more grammatically correct than what I just said. We just need to make sure that this order kind of maintains P then Q, but with those nots. So if not two given shapes are circles, then the shapes are not similar. And so that's going to be our inverse. And then the contrapositive means we both flip and negate them. So we put the shapes are similar, but we add the not in it. And then the shapes are not circles. That would be not Q and then not P. So that's our contrapositive. For this one, you're just going to have to remember the difference between those four kind of conditional statements. Okay, for number 7, this one's a bit long. But how we have to do this is there's a part A and a part B. First, we want to determine, are these triangles congruent or similar? And then how do we name that? And then part B is there's some sort of a transformation we can use to prove part A. And so to do that, what you need to do, and again, drawing a picture can kind of help you keep track and label the parts here. So if I have Q, R, S, and I want to prove that it's either similar to or congruent to TUV, I don't know anything about the angles, and so what I need to do is find my side lengths. And so to find the side lengths, I need to use the distance formula. So that formula actually exists right on your reference sheet. You can find it in the reference sheet here. So we can kind of work through finding the distance between all these sides. So we have to do it 1, 2, 3, 4, 5, 6 times to find all those side lengths. However, for this one, there are a couple of shortcuts we can take. For instance, Q to R, because those y coordinates are the same, they're both 0, we're basically just moving along the x-axis. From 2 to 6, that's a difference of 4. So that means the length of QR is just 4. We don't have to do the full distance formula there. We can just kind of get it that way. Similarly, with the Q and the S, the x coordinates are the same, so we're just moving from 0 to 4. That's just an upward movement of 4, or those are separated by 4 distance units. So QS is also 4. And then lastly, okay, we are going to have to find the distance, use the formula for RS. I'm not going to show that full thing now to save us a little time. I end up getting the square root of 32 if I leave this as a radical. I'm not even simplifying it. I'm just leaving it as a radical. And you can do that because we're going to compare to TUV. You'll see in a second. So for TUV, kind of similarly, if I looked at T to V, right, from 8 to 4, that's a distance of 4. So TV is 4. Same thing for U and V. The x coordinates are the same. The y coordinate is just different by 4. And so that's U to V. That's also 4. And lastly, I'm going to find the distance. I would actually use the distance formula between T and U. Again, I'm not going to show that here. But what I get is this is also the square root of 32. And so now I can say then that these two triangles must be congruent by the side congruence postulate. And so now the important part is we need to name it specifically. Specifically, the RS and the TU need to correspond in the naming statement. And so so C and D are both similarity, so we can cross those off. So it's either going to be A or B. And so I know RS needs to correspond to TU. And so here, if R and S take the second two spots, that means T and U needs to take the second two spots. Well, that's not true for A, but that is true for B. So those two correspond. That therefore we're going to name it that way. So by B, our two triangles are congruent, naming by those corresponding parts. Now, part B is asking us to, okay, if they're congruent, what transformation can we use to prove this? And so the way that I would do this is whether you have craft paper or even you can draw it by hand. I'm going to, I graphed it digitally because I'm not a good artist. And so I'm going to show it to you digitally. So how can I take this triangle, QRS, and transform it so that I get TUV, right? And so the way that I'm going to do that is I'm going to first translate this whole triangle to the right by 2 units, right? So when I do that, that puts this triangle now here. That puts QRS directly above, and we kind of get this mirror image. And so then the next thing I want to do okay, so I got cut off there as I was working on this problem. That first step, right? When I want to translate to the right means what I did is I added 2 to all of my x coordinates, right? That would result in this kind of taking this whole figure and translating it to the right. And so now this is directly above triangle TUV. And so what I need to do is I need to reflect this over the x-axis. So I want to reflect over the x-axis. And so I know that the rule for that is we're going to actually leave that x-coordinate alone. We're going to multiply the y-coordinates by -1. Well, that will put this coordinate there. And then because these ones are zeros, they're just going to kind of stay. But that would actually do the work of taking my triangle and reflecting it there. So if I go back to the problem at hand, right, back over here. So my coordinate rule is going to be, I want to translate it 2 to the right, and then I want to reflect it over the x-axis. And so that will be the answer to question number 7. Question number 8, we've got an inscribed angle and a central angle shown. So they're kind of telling us actually what type of angles these are in circle C. And so what we know is that for a central angle for x, it's going to be equal to whatever the measure of this arc is that it intercepts. For an inscribed angle, that's going to be equal to half of the measure of this angle arc. And so there are actually one of 2 ways you could write this relationship. Both will work because both are true, and this is a free response question. So the first way we could do it is, I know that y is going to be equal to half of x. I could write y equals 1/2 x, right? That is a true relationship because y is half the measure of this arc, right? Or if you want to write it the other way, you could write it as x is equal to 2 times y, right? Both of those are equivalent to each other, and both will work as an answer. Question number 9. So figure A is drawn on a coordinate plane. Transformations are performed on figure A to create figure B. Select the boxes to identify whether each transformation performed on figure A results in a congruent or non-congruent figure B. Okay, so they're not telling us specifically what the things are, but what we have to remember is that there are 4 types of transformations. We have what are called rigid or sometimes known as congruence transformations, which basically it preserves distances and angles. And so that's going to be our rotations, our reflections, and our translations, right? Those are known as rigid or congruence transformations. And then our non-rigid transformation is the dilation. And so the only thing that will result in a non-congruent figure is a dilation. And so I know for these last 2 here, these are both going to be congruent transformations because the rotation reflection is a congruent transformation or a rigid transformation. Now for these other 2, I have to figure out which one is a dilation rule or maybe not, right? This first one you might not know. I don't remember specifically which rule, but I know this is one of my rotation rules around the origin. And so because it's a rotation, that makes it a congruence transformation. This one here, because we're actually changing the length of the x and the y, that's what that 1/2 does. That's a dilation, right? That's a scale factor. And so that's going to give us a non-congruent figure when we complete that transformation. Question number 10. A line segment has an endpoint at 1, 1 and a midpoint at 1, -3. What are the coordinates of the other endpoint? So just generally speaking, you don't even need the graph to do this, but you can, right? I've got one endpoint, which is at 1, 1, and then the midpoint is at 1, -3. Okay, and so that means I want to find where the other endpoint. So this is one of my endpoints. This is the midpoint right here. So this is the midpoint. Let's call this E for endpoint, M for midpoint. And so I know because the x coordinate is the same, I know that these are actually only just 4 apart. And so if this is the midpoint, then the next point must be 4 below. And so if I go 4 more down from 1, -3, that's going to be at 1, -7. You could also use the midpoint formula here to solve this one, but that might be a little bit more work than what we need to do. So for question number 11, we've got this plane shown by kind of the dark gray cutting through our composite figure, which is the pyramid on top of the rectangular prism. And so I know that the intersection with sort of this rectangular prism is going to be a rectangle. But on the top part, since it's not intersecting through kind of our vertex here, it's only going to go up so far. At a certain point, we're kind of losing the top of that triangle of the pyramid. So our shape should look something like that. And so when I look at my options, I've got a rectangle, a trapezoid. Well, it's a combination of those. And so it's going to be a composite shape. It's not made up of a triangle because we don't get fully to that vertex there. It's going to be the composite made up of a rectangle and trapezoid, kind of how I've drawn it there. Question number 12. So we've got a triangle, TUV, with the coordinates shown. Complete the statements to explain why triangle TUV is a right triangle. So if I want to prove that something is a right triangle, I need to find a right angle. And so there's two ways to do that. You can either use Pythagorean theorem, or what this question is kind of hinting at is they're even telling you specifically, find the slope of TU, find the slope of TV, and we'll compare those slopes. So one of the things that you have to know is that our slopes for perpendicular lines is going to be opposite reciprocals. And so we've got our slope formula right there. We can use y2 minus y1. And so we just have to run through this really quickly. And they're telling us what to do. So the slope of TU is equal to 6 minus 5 over 6 minus 2. So that's equal to 1/4, right? And so this one actually gives us sort of, oh no, it doesn't. So we've got this here. I'll go type this in, 1/4. That's the slope of TU. The slope of TV is going to be equal to, it's TV, so I'm going to do -3 minus 5 over 4 minus 2. And that's -8 over 2, which is -4. And so these two numbers, right, -4 and 1/4, are opposite reciprocals. And therefore, triangle TUV is a right triangle because TU and TV are perpendicular, right? Because perpendicular lines form right angles. And so that's how we know that that's true. Okay, so we've got here another inscribed angle. And so using the same relationship that I talked about earlier, points A, B, and C lie on the circle as shown. They tell us the measures of the arc and of the angle. I know that this angle is half the measure of this arc here. And so I can do 1/2 of 3x and half of 16 and make that equal to this. But I know that's going to result in a fraction because of the 3. So rather, I'm going to do kind of the opposite of the relationship I showed you all earlier, which is I'm going to say 2 times 2x minus 6 is equal to 3x plus 16. Just to me, that makes it a little easier when I don't have to deal with the fraction. And so I get 4x minus 12 is equal to 3x plus 16, right? And so now you just have to run through this kind of logic or solve this problem. So I end up getting x is equal to 28. And so if I substitute that 28 into this expression for the measure of angle ABC, 2 times 28 is 56, and 56 minus 6 is 50. And so the measure of ABC is equal to 50. Question 14. A cone has a radius of 3 units, a height of 4 units, a slant height of 5. Which expression represents the surface area in square units of the cone? So for a cone, okay, the surface area is two things. We have the base of the cone. So the base is a circle, and so it's just pi r squared. And then the lateral surface area for a cone is equal to pi times the radius times the slant height. Now, here's the thing. You might not remember that. And so this is something, again, also on our reference sheet. So you can go reference a cone right here. Surface area is equal to base plus pi r. They have two different versions of showing the slant height, but there's a little key over here. Oops, it's a little hard to see here, isn't it? Where's the key? There's a key somewhere. Oh, there's the key. And it tells you the slant height is there or there, right? So slant height, all that information is there. And so all I have to do is kind of plug and chug. So for the base, it's pi times the radius squared. So that's my base. And then for my lateral area, it's pi times the radius. And then this is kind of just a distraction. We don't actually need the height. We want the slant height. And so that gives me 9 pi plus 3 times 5 is 15 pi. And so I'm going to write this answer in terms of pi, right? I see even these answers are in terms of pi. If I add 9 and 15, I get 24 pi, and so our answer is C. Next up, question 15. I got rectangle ABCD has the given side lengths. So rectangle ABCD. And so we got ABCD. AB is 5 and BC is 11. Okay. Rectangle PQRS is congruent to ABCD. What is the length of QR in units? Well, QR is going to correspond to BC, right? They're named by corresponding parts. And so QR must be congruent to BC. BC is 11. Therefore, QR is also 11. Easy peasy. Okay, question number 16. A two-dimensional figure and a vertical line are shown. The figure is rotated about the vertical line. Which object could be the result of this rotation? So we're rotating the bottom here. When we rotate it, it should basically look like a bowl that's not hollowed out. So because of that line on the top, when I rotate this all the way around kind of this axis, the top's going to be a circle, right? And so we see that for all these. It's not going to be B. But we're not rotating a rectangle. That would result in a cylinder, and we're not rotating a triangle, so this one's going to be A. Okay, lastly, which figure shows steps leading to the construction of a perpendicular bisector? Okay, and so for this one, you have to kind of know what your steps are for the perpendicular bisector. Essentially, you're going to take a compass, you make it a little bit more than halfway between the 2 points, and so you draw the arc so that they're crossing twice. So that's going to be option C. Now, option D is wrong because whoever made this, they made it the length of Q2. It looks like maybe about halfway, maybe a little bit less, but this is not quite following the procedure. You're just going to have to know this one. There's not really much we can do to reason that out from here. Last one I'm going to do for at least this video, number 18. Just like the other one, I'm going to take this kind of irregular shape. I'm going to rotate it around. Because of this gap here between the line and the shape, there should be a hole in the middle. So it should be B or D. And because we got kind of this curvy shape on the outside, I would expect to see that curve kind of happen in our shape. So this one's got the triangle instead of a curve. And so therefore our answer must be D.